Hello everyone, now we are starting your next topic, that is introduction to data link layer. The physical layer deals with the transmission of the signal over the different transmission medias. A reliable and efficient communication between two adjacent machines can be achieved via the data link layer. The layer basically deals with the frame formation, flow control, error control, addressing and link management. While sending data from source to destination, errors may get introduced. The data communication circuit have only a finite data rate and there is non-zero propagation delay between the instant a bit sent and the instant at which it is received. This limitation affects the efficiency of data transfer. The data link layer protocol used for the communication take care of all these problems. Data link layer is the second layer of the OSI reference model. It is above the physical layer. Next, the functions of the data link layer. The data link layer is supposed to carry out many specified functions. The effective data communication between two directly connected transmitting and receiving station, the data link layer has to carry out the number of specific functions like data transfer, frame synchronization, flow control, error control, addressing, and link management. Services provided to the network layer. The data link layer provides a well-defined services interface to the network layer. The principal services is transferring data from network layer on sending machine to network layer on destination machine. The transfer always takes place via DLL, the frame synchronization. The source machine sends data in the form of blocks called the frames to destination machine. The start and ending of each frame should be identified so that the frames can be recognized by the destination machine. Flow control. The source machine must not send data frames at the rate faster than the capacity of the destination machine to accept them. Error control. The error introduced during transmission from source to destination machines must be detected and corrected at the destination machine. Addressing. When many machines are connected together, the identity of individual machine must be specified while transmitting the data frame. This is known as addressing. The control and data on the same link. The data and control information is combined in the frame and transmitted from source to the destination machine. The destination machine must be able to separate out the control information from the data being transferred. Link management. The communication link between the source and destination is required to be initialized, maintained, and finally terminated for effective exchange of data. It requires the coordination and the cooperation amongst all involved stations. Protocol and procedures are required to be designed for the link management. Next point is error detection and correction. When transmitting of digital signals takes place between the two systems such as computers, the signal gets contained due to the addition of noise to it. The noise can introduce an error in the binary bits traveling from one system to the other system. That means a 0 may change to the 1 or 1 may change to the 0. This error can come a serious threat to accuracy of digital system. Therefore, it is necessary to detect and correct the errors. Next is error correction techniques. There are two most important techniques used for the error correction. First is forward error correction and second is automatic request for the retransmission. First is in forward error correction. In forward error correction, the receiver searches for the most likely correct code word. When an error is detected, the distance between the received invalid code word and all the possible valid code words is obtained. The nearest valid code is most likely to correct version of the receiving code word. Retransmission. Second is retransmission. In this technique, the receiver detects an presence of error in the received code words and requests the sender to resend the code word again. Retransmission is repeated until the receiving messages is error free. Next point is coding. Redundancy can be implemented by using various coding schemes. The block diagram of this coding explaining the process of coding as well as decoding system. At the sending end, the redundant bits are added to the data words using a well-defined process. The receiver detects and corrects the error and makes the decision on whether to accept or discard the receiving message. The two most important factors in any coding schemes are ratio of parity bits to data bits and how the robust the process is. The coding scheme can be divided into two types, is block coding and second is convolution coding. Next is linear block codes. The generation of block code is shown in the figure. To generate the and block code, the encoder accepts the information in the form of the blocks in the successive bits. At the end of each block, it adds a parity bit as shown in the figure. As these bits do not contain any information, they are called as the redundant bits. It is important to note that the parity bits are relatedly algebraically related to the message bits. Then the n bit code word is thus produced in the shown in the figure. Second is next is error detection in the block coding. We can add or detect the error using block coding if the following conditions are satisfied. First is the receiver has a list of all valid code word with it. The receiver code word is different than this valid code word. If it is received code word, it is invalid code word. The figure shows the process of error detection using block codes. The k-bit data words are applied to generator and applied to a generator or encoder. It applies rules and procedures to encode these bits and generate an n-bit code word. These code words are transmitting using unreliable transmission to the receiver. Each transmitted code words may change due to the noise while traveling from the transmitter to receiver. If the received code word is same as one of the valid code word, then the receiver extracts the data word and uses it without any changes. But if the received code word is not valid, it is discarded. However, if a corrupted received code word matches with the valid code word, then the error go to unnoticed as the receiver thread is the code word as the valid code word. This type of coding can be detected only a single error. Multiple errors remain undetected. Next is error correction process. The process of error correction is the much more difficult as compared to the error detection. In the error correction, the receiver has to detect the presence of error in the received code words and correct it too. Therefore, more redundant bits are required to be sent for the error correction than those of required for error detection. The figure explains how the block coding can be used for the error correction. Note that the block schematic of the sender and receiver for the error correction is the same as that of error detection, but the role of checker block is much more complex in the error correction process. Next is linear block codes. The block codes can be of two types, linear block codes and non-linear block codes. Almost all block codes used today are the linear block codes. The non-linear block codes are not used widely as their analysis and implementation is difficult. A linear block code is defined as the code in which the exclusive or modulo 2 addition two valid code words would be produced and another valid code word. For a linear block code, the minimum Hamming distance is equal to the number of ones present in the non-zero valid code word, which has the smallest number of ones. Some linear block codes are one, simply parity check code, and two is Hamming code. Out of this, parity check codes are designed for the error detection purpose, whereas Hamming codes are designed for the error correction codes. Next is cyclic code. Binary cyclic codes are basically linear block codes which are actually satisfy all the restrictions that the block code is supposed to satisfy, but the additional constraint on which binary cyclic code is called as a cyclic property. Properties of cyclic codes. A binary code is said to be cyclic code if it exhibits the following property. First property is linearity property. A code is said to be linear if the sum of two code words produces another valid code word. This property states a cyclic codes are linear block codes. And second property is cyclic property. A code is said to be cyclic if the cyclic shift of any code word results into the formation of another code word. Next is cyclic redundancy check. This is the type of polynomial code in which a bit stream is represented in the form of polynomial with coefficient of 0 and 1 only. Polynomial arithmetic use a modulo 2 arithmetic, that is addition and subtraction, are identical to the XOR. For a CRC codes, that is cyclic redundancy codes, the sender and receiver should agree upon the generated polynomial. A code word can be generated for the given data word polynomial with the help of the long division. This technique is more powerful than the parity check and checksum error detection. CRC works on the principle of binary division. A sequence of redundant bits called CRC or CRC remainder is appended at the end of the message. We will call this word as the appended message word. The appended word thus obtained becomes exactly divisible by the generator word corresponding to the g of x. The sender appends the CRC to the message word to form a code word. At the receiver, this code word is divided by the same generator word which correspond to g of x. There is no error if the remainder of this division is 0, but non-zero remainder indicates the presence of the error in the received code word, such as erroneous code word is rejected. Next is, and the last point is checksum. Checksum is the last error detection method. It is used in the internet by many protocols. The concept of checksum is based on the principle of redundancy. This is very similar to the linear block codes and cyclic codes. Some of the protocols still use checksum for error detection, but nowadays CRC is more preferred. Hence, the CRC is fast replacing the checksum. Checksum is used in the data link layer level, and CRC is used in some layers other than the data link layer. Simply parity cannot detect two or even number of errors within the same word. One way to overcome this problem is to use the sort of two-dimensional parity. As each word is transmitted, it is added to the previously sent word and the sum is written at the transmitter. Each successive word is added in this manner in the previous sum. At this end of the transmission sum, called as a checksum, up to the time is sent. The error normally occurs in burst. The parity check method is not useful in the detection of error under such conditions. The checksum error detection method can be used successfully in the detecting such errors. In the method, a checksum is transmitted along with the every block of data bytes. In this method, an 8-bit accumulator is used to add the 8-bit bytes of the block code to find the checksum byte. The carrier of MSB are ignored while the finding of the checksum byte. The generator of the checksum will be clear if you refer the given example on the net. Thank you.